In this video, we are going to discuss Graeffe's root squaring method, which is an iterative method that is used to find all the roots of a polynomial, which is of the form f of x equal to a n x power n plus a n minus 1 x power n minus 1 plus and so on a1x plus a naught. Sometimes we simply write f of x equal to 0. So f of x will be of this form. Now, before going to discuss what actually the procedure to find using Graeffe's method, now we need to recall some points. So first point is Descartes' rule of sign. So this rule says if you consider the polynomial f of x equal to 0, then number of positive real roots of f of x is at most the number of sign changes in f of x equal to 0. If you consider a polynomial, then number of positive real roots of that polynomial is at most the number of sign changes in that polynomial. Similarly, the number of negative real roots of f of x equal to 0 is at most the number of sign changes in f of minus x equal to 0. For example, if you consider this polynomial f of x equal to x cube minus 2x square plus x plus 1, then you can check here plus minus plus plus. There are two sign changes. So this polynomial has at most two positive real roots. At most two positive real roots. Now if you replace x by minus x here, then we will be getting minus x cube minus 2x square minus x plus 1. Now here minus 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 plus. There is only one sign change. So at most one negative real root. This is what Descartes' rule of sign says. Okay. So next important point is, so this rule, Graeffe's root squaring method, this method actually gives the absolute value of roots of the polynomial. If you consider f of x, and if lambda 1, lambda 2, and so on, lambda n are the roots of f of x, then using Graeffe's method, we will be able to find modulus of each of this root. So sign of the root should be determined by substituting the root in the given equation. So we don't get sign, we get only absolute value of the root. Now, if all the roots are real numbers, nothing to worry. If suppose the polynomial has complex root, say for example, lambda 1, lambda 2 equal to p plus or minus iq. Okay, then assume remaining roots are all real, lambda 3, lambda 4, and so on, lambda n. Then how to find this lambda 1 and lambda 2? That means we need to determine p and q. How to determine this p and q? For that, you have to use one relation that connects the coefficients of x and roots of the polynomial. So ಒಂದು relation ಇದೆ, ಅದೇನು ಹೇಳುತ್ತೆ ಅಂತಂದ್ರೆ sum of all roots lambda 1, lambda 2, lambda 3 plus and so on lambda n, that will be equal to minus of, say the polynomial you are considering is of this form a n x power n plus a n minus 1 x power n minus 1 and so on a naught, then it will be negative of coefficient of x power n minus 1. It will be negative of a n minus 1. Now, if you sum of these two, lambda 1 and lambda 2, obviously plus iq minus iq get cancelled. You get 2p plus lambda 3 plus and so on plus lambda n will be minus of a n minus 1. From this method, you will be able to find all these roots, especially for complex roots. You get modulus of lambda 1, modulus of lambda 2, and modulus of lambda 1, that will be actually equal to square root of p square plus q square. So this you can determine by Graeffe's root method. Then using this rule, you have to determine p. Then from that, you have to find q. Using this relation, find q. Then you will be able to determine lambda 1 and lambda 2 complex roots. So okay, this is the procedure. I mean, points need to recall to discuss Graeffe's root method. Now we are going to discuss the working procedure. Working procedure. First, consider the polynomial. Consider the polynomial, that is f of x equal to 0, and use Descartes' rule. This gives a count of positive and negative real roots. Second one, so I have to write down the iteration table. Write the table. Here table should be written in this form. First entry of the table m, second one 2 power m. Then you have to write the coefficients of the polynomial starting from higher degree. an, an minus 1, an minus 2, and so on, a1, a0. You must always start from 0 here. So m should be 0 first. Then obviously 2 power m will be 1. Then here you have to write an square, an minus 1 square, an minus 2 square, plus and so on, a1 square, a0 square. In the next row I have to write here below an square ಕೆಳಗಡೆ ಮತ್ತೆ a0 ಸ್ಕ್ವೇರ್ ಕೆಳಗಡೆ 0 ಬರುತ್ತೆ. ಇಲ್ಲಿ an minus 1 whole square ಕೆಳಗಡೆ I have to write minus 2 into product of these alternating terms an minus 2. Then here minus 2 into product of these alternating terms minus 2 into an minus 1 an minus 3. Continuing this way, here actually get minus 2 into a2 a0. Okay. After writing this, you have to add these entries. You have to add these entries. Whatever you get here, that values should be taken as bn. So here bn, this is say bn minus 1, bn minus 2, and so on. bn, okay, it is b1, b1, then b0. Here m value will be 1 and 2 power m will be 2. Next, same procedure you have to repeat. Here you have to write bn square, bn minus 1 whole square, bn minus 2 whole square, and so on, b1 square, b0 square. And here 0 and 0. So in this place I have to write minus 2 into bn minus 2, minus 2 into bn minus 1 bn minus 3, and so on, minus 2 into b2 b0. Then adding these values you get 1. Okay, it is increased to 2. Yes. Now 2 power 2 will be 4. And here you get cn minus 1, cn minus 2, so on, c1, c0. You have to continue this process until, see, here you had an, then you had bn, then you had cn. At each step you have to check whether an square is equal to bn. You have to check the difference an square and bn. If the difference is very high, then you have to repeat one more iteration. This is actually first iteration, this is second iteration, and this is third iteration. If an square and bn, the difference of those two terms is high, ಇವೆರಡರದ್ದು ಡಿಫ್ರೆನ್ಸ್ ತುಂಬ ಜಾಸ್ತಿ ಇದ್ದರೆ ಇನ್ನೊಂದು ಇಟ್ರೇಷನ್ ಮಾಡಬೇಕು. ನೆಕ್ಸ್ಟು ಸಿ ಎನ್ ಬರುತ್ತೆ. ಸೊ ಬಿ ಎನ್ ಸ್ಕ್ವೇರ್ ಮತ್ತು ಸಿ ಎನ್ ನೋಡಬೇಕು. ಅವೆರಡದು ಡಿಫ್ರೆನ್ಸ್ ಮತ್ತೆ ಜಾಸ್ತಿ ಇದ್ದರೆ ಇನ್ನೊಂದು ಇಟ್ರೇಷನ್ ಮಾಡಬೇಕು. ಅಲ್ಲಿ ನಮಗೆ ಸೇ ಡಿ ಎನ್ ಮೈನಸ್ ಒನ್, ಡಿ ಎನ್ ಮೈನಸ್ ಟು ಆ್ಯಂಡ್ ಸೊ ಆನ್ ಡಿ ಒನ್ ಡಿ ನೋಟ್ ಬರುತ್ತೆ. ಸೊ ಸಿ ಎನ್ ಸ್ಕ್ವೇರ್ ಮತ್ತು ಡಿ ಎನ್ ಚೆಕ್ ಮಾಡಬೇಕು. ಸೊ ಆಲ್ಮೋಸ್ಟ್ ಕ್ಲೋಸ್ ಇದೆ ಅಂತಂದರೆ ಯು ಕ್ಯಾನ್ ಸ್ಟಾಪ್ ದ ಪ್ರೊಸೀಜರ್. ದಟ್ ಈಸ್ one important point you have to remember. So now suppose finally you got dn minus 1, dn minus 2, d1, d0 and so on. Then the roots of the equation, actually roots ಯಾವ ರೀತಿ ಇರುತ್ತೆ, lambda 1, lambda 2, lambda n ಅಲ್ವಾ. lambda 1 will be modulus of ಇಲ್ಲಿ ಸೊ ಇದು ನೆಕ್ಸ್ಟ್ ಇಟರೇಷನ್ ಬಂದಿದ್ದಲ್ಲ, ಫೋರ್ತ್ ಇಟರೇಷನ್, ಇಲ್ಲಿ m ವ್ಯಾಲ್ಯೂ 3 ಆಗಿರುತ್ತೆ, 2 power m 8 ಆಗಿರುತ್ತೆ. ಇದು ಕರೆಸ್ಪಾಂಡಿಂಗ್ ಆಗಿ ಏನು ವ್ಯಾಲ್ಯೂ ಇರುತ್ತೆ ಅದನ್ನು ತಗೋಬೇಕು. These values I have to take. dn minus 1 divided by dn whole power 1 by 2 power m ಇಲ್ಲಿರುತ್ತಲ್ಲ, ಈ ವ್ಯಾಲ್ಯೂ ಇಲ್ಲಿ ಬರುತ್ತೆ. lambda 2 will be modulus of dn minus 2 divided by dn minus 1 whole power 1 by 2 power m and so on. So this is one point. Second point, you have to look into terms, the sign of these terms. ಇಲ್ಲಿ ಯಾವುದೋ ಒಂದು ಪರ್ಟಿಕ್ಯುಲರ್ ಟರ್ಮ್ಗೆ ಇಲ್ಲಿ ಎ ಎನ್ ಮೈನಸ್ ಟು ನೆಗೆಟಿವ್ ಇದೆ, ನೆಕ್ಸ್ಟ್ ಬಿ ಎನ್ ಮೈನಸ್ 1 ಪಾಸಿಟಿವ್ ಬಂತು, ನೆಕ್ಸ್ಟ್ ಸಿ ಎನ್ ಮೈನಸ್ ಟು ನೆಗೆಟಿವ್, ಡಿ ಎನ್ ಮೈನಸ್ ಟು ಪಾಸಿಟಿವ್. ಈಗ ಸೈನ್ ಆಲ್ಟರ್ನೇಟಿಂಗ್ಲಿ ಚೇಂಜ್ ಆಗ್ತಾ ಇದ್ರೆ ಆ ಈಕ್ವೇಷನ್ಗೆ ಇಫ್ ಸೈನ್ ಆಫ್ ಕೋಎಫಿಷಿಯೆಂಟ್ changes alternatively, then from that your conclusion is f of x has complex root. That will be actually, say ಈಗ ಒಂದು ಎಕ್ಸಾಂಪಲ್ ಗೋಸ್ಕರ ಇದನ್ನು ತಗೋಣ. say a1 ನೆಗೆಟಿವ್ ಇದೆ, b1 ಪಾಸಿಟಿವ್, c1 ನೆಗೆಟಿವ್, d1 ಪಾಸಿಟಿವ್, ಈ ರೀತಿ ಬಂದಿದ್ರೆ then modulus of c I whole square, whatever the value of I, that depends on which coefficient you are getting alternative sign, that will be modulus of di minus 1 divided by di plus 1 whole power 1 by 2 power m, ಅಥವಾ modulus of lambda I will be then modulus of di minus 1 divided by di plus 1 whole power 1 by 2 power m plus 1 ಆಗುತ್ತೆ. So from this you get all the roots of the given polynomial. So this is how we can apply Graeffe's root squaring method to find roots of the polynomial.